Today I talk about electromagnetic induction. Okay. If you have a coil and you connect between two terminals of a coil galvanometer, okay, and plunged magnet, north pole or south pole, okay, close or away. So electric current is generating inside the coil. It's called induction. Okay. If you close or away this spool with the coil, you observe electric current intensity generating inside the coil. Okay. Electromotive force is generating. Electromotive force directly proportional with the number of turns. If you increase number of turns, so electromotive force increase, and vice versa. Electromotive force directly proportional with the rate of change of magnetic flux. Okay. From 1 and 2, we obtain that electromotive force directly proportional with the number of turns and change of magnetic flux. So electromotive force equals the constant N delta phi over delta T. If you have number of turns 1 and rate of change of magnetic flux 1 Weber per second, so electromotive force has a value 1 volt. So constant equal 1. If electromotive force 1 volt, 1 turn, and rate of change of magnetic flux Weber per second. So constant equal 1. Means electromotive force equals N delta phi over delta T. This equation gives us Faraday's law. Faraday's law, first, electromotive force directly proportional with the rate of change of magnetic flux. Second, electromotive force directly proportional with the number of turns. Okay? Lenz's rule gives this equation negative. It's called Lenz's rule. What is the Lenz's rule? Okay. Lenz's rule if you have a coil, the galvanometer, and the other, the third, fourth, okay, between the terminals of a coil galvanometer, if you close a magnet north pole, okay, is plunged inside the coil or away. When plunged means close, electromotive force or electric current induced generate inside the coil. Okay? Lenz's rule, electric current induced must be in a direction, such as to change the opposite producing it. Means North Pole near electromotive force generate. Electromotive force inside the coil opposes the change producing it. Why? Electromotive force inside the coil solenoid has a magnet, means N generate north pole near this north and south away. So electric current passes through from south to north. If you have north and away from this coil, okay, electric current induced inside the coil opposes from this north pole. How? Electromotive force generate magnetic field inside the solenoid as a magnet, so opposes this north means south to attract that other to repel N. So the direction of electric current induced passes through S from to N. Pointer, okay, deflect like this and other opposite, or vice versa. If you have a south pole, close this coil, electromotive force is generating inside the coil. So generate magnetic field. Inside the solenoid, magnetic field as a magnet, okay, opposes this south pole. How? Close as similar, and this side north. Why? To repel. So a current from passes through the coil from S to N. If you away south pole from this coil, okay, electromotive force or electric current induced in the coil must be opposite this south pole. How? Generate magnetic field. Magnetic field, okay, opposite this south pole. So generate north pole to attract, okay, and south away. So electric current induced pass through from S to M. Means if you close pointer deflect like this and the other like this, okay, or vice versa. So I write general law: electromotive force equals negative N delta phi over delta T. This equation gives us definition of electromotive force, okay, induction, okay, give us Lenz rule, okay, measuring unit. Definition of electromotive force induction or electromagnetic induction, okay, electromotive force or electromagnetic induction. Okay, what is the electromotive force induction? What is the electromotive force induction? It's generated inside the coil. If you change magnetic flux, okay, Weber per second. But electromagnetic induction, it's a phenomenon of generating electromotive force induction in a coil if you exchange magnetic flux. Lenz's rule: electromotive force or electric current induced must be in a direction, such as always, the change producing at. What's the producing at? Change of magnetic flux, north or south. Okay? Lenz's rule, so Lenz's rule is used for determining the direction of electric current induced inside the coil. Okay? Measuring unit: electromotive force, volt equals N number of turns, phi over delta T, يبقى Weber per second. Means volt equal Weber per second over 1 volt per second equal Weber. Okay? Thanks. Notes for solving problems, okay, related with Faraday's law. Since EMF equals negative N delta phi over delta T. Okay? If you have change of magnetic field, change of magnetic flux for phi 1 to phi 2 means phi 2 greater than phi 1. I substitute EMF equals negative N phi 2 minus phi 1 over delta T. If magnetic field intensity is given, I substitute phi equal AB. Okay, so EMF equal negative N delta phi over delta T. EMF equal negative N delta over delta T AB. If B is changed, so EMF equals negative N, okay, B changed, so a constant, B changed a constant, يبقى negative N A delta B over delta T. So I substitute EMF equal negative N A B2 minus B1 over delta T, where A is constant. If B is constant, okay, I replace A with B. We find that EMF equal negative B delta E over delta T. So I substitute EMF equal negative B, okay, times B2 A2 minus, since EMF equal negative N delta phi over delta T. If you have a coil, then it rotate half cycle or inverted, rotate 100 degree. So electric motive force equal negative N delta phi over delta T times 2. Electric motive force equal negative N delta phi over delta T. Since electromotive force equal negative N delta phi over delta T, by dividing R, electromotive force over R equal negative N delta phi over delta T over R. By dividing voltage over R, give us I. So I equal negative N delta phi over delta T over R. Where I, Q over T. Q over T means the charge equals negative N delta phi over R delta T. T cancel. So Q charge equal negative N delta phi over R. Good luck. Thanks.